Right, so I need to tell you about something that happened this week.
The Anthropic thing?
Yes, but not just that. It's three completely different stories that all point to the same shift. AI agents getting their own computers, quantum batteries that work backwards from normal physics, and farm robots testing in actual mud instead of clean labs. They're all about the same thing, breaking free from constraints we thought were just how things work.
Okay, I'm listening.
Right, so let's start with the Claude thing because honestly, this one surprised me. Felix Rieseberg from Anthropic did a full podcast about Claude co-work, and at first I thought, okay, another AI feature. But the more he explained it, the more I realized this is actually fundamental.
They gave the AI its own virtual machine?
Exactly, its own computer environment, completely sandboxed.
Wait, why does that matter? Isn't that just safety?
It's both safety and capability. That's what makes it interesting. When an agent runs on your machine, it's limited to whatever you've pre-approved. It can only use the tools you've given it access to. It can't install anything. It can't manage files. But in its own VM, it can do everything we do on our computers. Install software, run scripts, manage workflows, all without touching your system.
Right, and Felix talks about this as the future of knowledge work automation. Because suddenly the agent isn't trapped in a chat window anymore. What?
I'm just thinking about what that means practically. If it's running locally, you're not sending data to the cloud. You're not rate limited. You're not waiting for API approvals.
Yes, that's exactly it. And apparently people are comparing it favorably to OpenClaw, which tells you something about how seriously this is being taken.
We covered OpenClaw skills this week as well. 5-layer security model, intelligent routing, the whole production stack.
Right, and that's the other half of this. Because giving agents more freedom means you need better guardrails. The guide that came out this week, it walks through the whole thing. How do you test AI systems that aren't deterministic? How do you monitor for drift? How do you deploy confidently when the system makes different decisions based on context?
That last bit is huge. Because I've seen teams try to treat AI agents like traditional software, write some unit tests and ship it, and it doesn't work like that.
No, the outputs vary by design. That's the point of agents.
So the testing has to be different. You're not checking for exact outputs. You're checking for reasonable behavior within boundaries.
Which is much harder.
Much harder. But the guide breaks it down. Prometheus, Grafana, RAG knowledge bases, the whole production monitoring stack. And honestly, this is the kind of thing I wish we'd had 6 months ago when we were figuring this stuff out.
There's a related piece this week that clarifies something important.
The agentic platforms thing?
Yes, what actually is an agentic AI platform? And how is it different from workflow automation? Because I keep seeing these terms used interchangeably, and they're not the same thing at all.
Go on.
A workflow engine with an LLM step bolted on. That's not an agentic system. An agentic platform gives software a goal, gives it tools, and then lets it reason at runtime about how to proceed. The difference is architectural. Workflow automation is optimized for predefined paths. You know exactly what's going to happen in what order. Agentic platforms are optimized for runtime judgment, the kind of ambiguous, context-dependent work that humans spend most of their time on.
Okay, but why does that distinction matter practically?
Because teams are making real decisions right now about what to invest in, and getting it wrong costs money.
Exactly. The article mentions millions sunk into projects that never shipped because they picked the wrong architecture.
Right. So what's the framework?
Simple. If the path is known, use workflow automation. If the system has to interpret context, choose tools dynamically, and adapt when the first approach doesn't work. You need an agentic platform. Most production systems will use both.
That makes sense. And it ties back to the Claude co-work thing, because that's about giving agents the freedom to choose their own tools at runtime.
Yeah, exactly.
Okay, so staying with this theme of breaking constraints, there's a quantum battery story this week that honestly made me do a double take.
The Australian one?
Yes. So, researchers have built a functional quantum battery, not a simulation, not a theoretical model, an actual working prototype that charges, stores, and releases energy.
And it scales backwards.
Right, that's the bit that made me pause. Most technologies hit scaling problems. Quantum batteries do the opposite. The bigger they get, the faster they charge.
That's not how batteries work.
I know. That's what makes it so interesting. It's a fundamental advantage, not just incremental progress.
The physics is counterintuitive. In a classical battery, you're moving ions through a medium. Bigger battery means longer paths, more resistance. But quantum batteries use entanglement. More quantum cells means more parallel charging pathways. The system becomes more efficient as it scales up.
Okay, but we're still in proof of concept territory, right? This isn't powering data centers tomorrow.
No, not yet. But the transition from theory to working prototype, that's the milestone. And what stood out to me in the research paper is the confidence. They're not saying if this works, they're saying it works. And here's how we scale it.
Think about what this could mean for AI infrastructure. Training large models requires massive energy. If you could charge storage systems faster at scale, that changes the economics.
Or edge devices, sensors, wearables, anywhere you need compact energy storage with fast charge cycles.
Exactly. This is one of those breakthroughs that shifts timelines. And honestly, I wasn't expecting quantum news to sound this concrete. But here we are.
It's a pattern we've been tracking, quantum moving from theory to implementation. We covered the classical computer-solving quantum problems a few weeks back. That was unexpected too.
Right. Good point. Okay, so moving to something completely different but weirdly related, agricultural robotics.
The living lab thing.
Yes, so Reservoir Farms just opened, and this isn't just another startup incubator. 12 robotic startups, 24 acres of actual farmland, real crops, real dirt, real weather, and partnerships with the big names, Bayer, Driscoll's.
Okay, but why does that matter? What's different about this?
Agricultural robotics has always had this problem. You can build a brilliant weeding robot in your warehouse, test it for months on controlled plots, and then you deploy it on an actual farm and it fails, because real fields aren't like test environments.
Right. The lighting changes, the soil varies, plants grow unpredictably. All the variables you controlled in the lab, they're not controlled anymore.
So Reservoir Farms gives them access to the real thing from day one.
Exactly. BHF Robotics is testing electric weeding. Luma is working on precision irrigation. Beagle Technology is building embodied AI for pruning. And they're not testing in isolation. They're iterating together, sharing insights, compressing years of R&D into weeks because they have immediate access to real-world validation.
This is infrastructure for physical AI, and it's the kind of thing that doesn't make headlines, but changes everything for the teams actually building.
Yeah, I was going to say, this feels like what the cloud did for software. You don't need to build your own data center anymore, you just use it.
That's a really good comparison, actually. And there's a related announcement this week that goes even further with that idea.
Nebius and NVIDIA.
Yes, so they're calling it a physical AI cloud, and at first I thought, okay, marketing speak. But when you dig into what they've actually built, it's genuinely useful.
The problem they're solving is this. If you're building a robot today, you need 3 separate computer systems. One for simulation, one for training your models, and one for actually running the robot in the field. That's expensive, that's slow, and it's a massive barrier for smaller teams.
So what they built is a single integrated platform: GPU compute, simulation, synthetic data generation, edge deployment, all in one place.
And how much does that actually help?
RoboForce, one of the early users, reported a 70% reduction in pipeline setup time.
That's significant.
If you're a robotics startup and you can cut 70% of your infrastructure overhead, that changes what you can build. That changes how fast you can move.
Right. And this is what making physical AI accessible actually looks like. Not just better models, better infrastructure. And between Reservoir Farms and the Nebius platform, you're seeing the pieces come together.
Yeah.
What?
I'm just thinking, all 3 stories today are about the same thing. Breaking constraints, AI agents trapped in chat windows. Now they get their own computers. Quantum batteries that should get worse as they scale, but they get better. Farm robots that had to test in labs. Now they test in real fields.
Oh, that's good, you're right.
The constraints we're used to, the ones that feel like they're just how technology works, a lot of those are dissolving.
And the teams that see that early, they're the ones building the next decade.
Yeah.
Okay, so there's one more piece I want to mention before we wrap, and this one's really practical. It's about testing, UI tests specifically, and why they break every sprint.
Oh, I know this pain.
Right? So the article walks through why this happens. Your test target elements by CSS selectors, or DOM position, and then someone changes a class name, or moves a button, or refactors the structure, and suddenly all your tests are red, not because the app is broken, because the selectors are brittle.
The solution is beautifully simple. Stop targeting elements by implementation details. Start targeting them by what the user sees.
ARIA role and visible text.
Wait, say that again?
Instead of button.submit-btn-class-123, you target button with role submit that says complete purchase. Those attributes represent what the user actually sees and interacts with. They're semantic, they're stable.
And bonus, they double as accessibility audits. If your test can't find an element by its role and label, neither can a screen reader.
Oh, that's clever.
Right? You're not just making tests resilient, you're improving usability at the same time.
This is one of those ideas that feels obvious once you see it. But most teams are still fighting brittle selectors every sprint.
Yeah, and honestly, it ties into something we've been noticing across all the stories today. The best solutions don't add complexity, they remove it. They work with how things actually are, not how we wish they were.
Agents get their own environment so they don't break yours. Quantum batteries use entanglement, so scaling helps instead of hurts. Farm robots test in real conditions from day one, and UI tests target what users see, not what developers build.
Exactly, it's all about removing the artificial constraints.
There's one more story we should mention, brief one.
Go on.
Pentagon exploring AI training on classified data. Secure environments where companies like OpenAI and xAI could train models directly on classified intelligence.
That's complicated.
Very data leakage, cross-department security, model weights that encode sensitive patterns. If you train a model on classified data, does the model itself become classified? How do you update it? How do you audit it?
These aren't theoretical concerns either. These are questions that need answers before the first training run starts.
But the Pentagon clearly sees value in domain-specific models. They want models trained on their data, using their terminology, understanding their context.
That's the same insight we saw earlier. Generic models guess, trained models know. But the stakes here are obviously higher.
Yeah, this is genuinely uncharted territory, and I'm curious to see how they solve the security challenges, but we'll keep tracking it. Okay, so looking across everything today, what's the takeaway?
The constraints we thought were permanent, a lot of them are just habits, things we got used to.
AI agents don't need to stay in chat windows. Quantum systems don't have to follow classical scaling rules. Farm robots don't need perfect lab conditions.
And the teams that question those assumptions, they're the ones building what comes next. What do you think? Are there constraints in your work that feel permanent but might not be? Let us know in the comments. We'd genuinely love to hear your perspective on this.
Good question.
Right, so that's it for today. All the links are in the description below. Full articles, references, everything we talked about. And if you want the complete analysis with all the context we couldn't fit here, the web digest is at luma.marbl.codes. That's MARBL.codes. If you're enjoying these conversations, hit subscribe so you don't miss the next one. We do this every weekday, and honestly, we're just getting started. Oh, and quick mention, if you're working in AI or exploring talent in this space, Atlas AI Talent is worth checking out. They're building something interesting around technical recruitment. Links in the description.
See you tomorrow.
Thanks for listening. Take care.